Understanding breaker capacity within an electrical panel is crucial for safety and code compliance. According to the National Electrical Code, the number of breakers you can install in a panel is directly related to the number of available spaces. In a 40-space panel, you can install a maximum of 40 individual breakers. However, the overall amperage of those breakers compared to the main panel rating is what's important for this topic. When a panel is fully populated with breakers, such as 40 20-amp breakers in a 200-amp panel, it's important to consider the total potential load. The fact that the panel is full does not immediately indicate a problem. The key is whether the connected load to all those breakers exceeds the panel's rating. Here's how to think about it. A 200-amp panel supplies a maximum of 200 amps. If all 40 20-amp breakers were fully loaded simultaneously, that would represent a potential draw of 800 amps, because 40 multiplied by 20 equals 800. That is an issue, but real-world electrical systems rarely operate with every circuit at maximum load simultaneously. This concept is addressed in the NEC through demand factors and load calculations. Demand factors recognize that not all electrical loads operate continuously or at their full rated capacity at the same time. For example, lighting circuits might only be used in the evenings, and appliance circuits might only be used intermittently throughout the day. Load calculations involve estimating the expected maximum demand on the electrical system based on the types of loads connected and their anticipated usage pattern. The NEC provides specific guidelines for calculating these demand factors and applying them to determine the appropriate size of the service and panel. When calculating the load on a panel, the NEC allows for the application of demand factors, which reduce the calculated load based on the assumption that not all circuits will be fully loaded at the same time. However, even with demand factors, it's essential to ensure that the calculated load does not exceed the panel's rating. A common practice is to consider the continuous load on a breaker. The NEC generally requires that breakers be loaded to no more than 80% of their rating for continuous loads. A continuous load is defined as a load that operates for 3 hours or more at a time. So, for a 20-amp breaker, the maximum continuous load should not exceed 16 amps. This rating is to account for the heat generated by the breaker when it is continuously loaded, which can cause it to trip prematurely if overloaded. In a scenario where you have 40 20-amp breakers in a 200-amp panel, and each breaker is loaded to 80% of its rating, which is 16 amps, the total load would be 640 amps. This total load of 640 amps significantly exceeds the 200-amp capacity of the main panel. Such a situation indicates a serious problem and poses a significant risk of overloading the panel. If the total load on the panel exceeds its rating, the main breaker is designed to trip. The main breaker is a safety device that protects the panel and the electrical system from overcurrents. When the current flowing through the main breaker exceeds its rated capacity, the breaker will trip, interrupting the flow of electricity to the entire panel. This tripping action prevents damage to the panel, wiring, and connected equipment. The most immediate consequence of overloading a panel is the tripping of the main breaker. This will result in a complete loss of power to all circuits served by the panel. While this can be inconvenient, it is a necessary safety measure to prevent more serious problems. Repeatedly tripping the main breaker is a clear indication of an overloaded panel and should not be ignored. Ignoring repeated breaker trips and attempting to reset the breaker without addressing the underlying cause can be extremely dangerous. Overloading an electrical panel can lead to several serious consequences, including overheating of wires and connections, damage to electrical equipment, and an increased risk of electrical fires. Overheating of wires and connections is a significant concern. When wires are overloaded, they generate excessive heat. This heat can damage the insulation on the wires, leading to short circuits and ground faults. Overheated connections can also loosen and corrode, further increasing the risk of electrical problems. Overloading can also damage electrical equipment. Electrical equipment is designed to operate within a specific voltage and current range. When equipment is subjected to excessive current, it can overheat and fail prematurely. This can result in costly repairs or replacements. Perhaps the most serious consequence of overloading an electrical panel is the increased risk of electrical fires. Overheated wires and connections can ignite nearby combustible materials such as wood, insulation, and paper. Electrical fires can spread rapidly and cause significant damage to property and pose a serious threat to life safety. To prevent overloading an electrical panel, it's important to perform regular load calculations to determine the expected maximum demand on the system. Load calculations should be performed whenever new circuits or equipment are added to the panel. It's also important to ensure that all electrical work is performed by qualified electricians who are familiar with the NEC and local electrical codes. Regular inspections of the electrical panel can also help identify potential problems before they become serious. Look for signs of overheating, such as discoloration of wires or breakers, and listen for any unusual noises coming from the panel. If you suspect that your electrical panel is overloaded, it's important to take immediate action. Contact a qualified electrician to inspect the panel and perform a load calculation. The electrician can then recommend appropriate solutions, such as upgrading the panel, redistributing circuits, or reducing the load on certain circuits. Upgrading the panel involves replacing the existing panel with a larger one that has a higher amperage rating. This can provide additional capacity to accommodate the existing load and any future expansion. Redistributing circuits involves moving some of the circuits from the overloaded panel to another panel with available capacity. This can help balance the load across multiple panels and reduce the risk of overloading any one panel. Reducing the load on certain circuits involves identifying circuits that are heavily loaded and finding ways to reduce their demand. This might involve replacing energy-intensive appliances with more efficient models, using timers or occupancy sensors to control lighting, or simply being more mindful of energy consumption. In summary, while it is technically permissible to fill a 40-space panel with 40-20 amp breakers, the critical factor is ensuring that the total load on the panel does not exceed its rated capacity. The NEC provides guidelines for calculating load and applying demand factors, but it's essential to prioritize safety and prevent overloading the panel. If the main breaker trips frequently, or if you suspect that the panel is overloaded, contact a qualified electrician to inspect the system and recommend appropriate solutions. The scenario presented raises important considerations about electrical panel loading, breaker capacity, and the National Electrical Code requirements. The primary question concerns how many 20-amp breakers can be installed in a 40-space panel, the potential for overloading a 200-amp panel filled with these breakers, and the possible consequences of such overloading. The NEC allows one breaker per space, so a 40-space panel can physically accommodate 40 breakers. The concern arises when the total potential load of all breakers significantly exceeds the panel's main breaker rating. In this instance, 40 20-amp breakers have a combined capacity of 800 amps, which is far greater than the 200-amp rating of the main breaker. This doesn't automatically mean the panel is overloaded in practice, but it highlights the importance of understanding load calculations and demand factors. Electrical panels and their associated breakers are designed with safety margins. Breakers are designed to trip when the current exceeds their rated capacity, preventing overheating of wires and potential fires. The main breaker protects the entire panel, tripping if the total load surpasses its 200 amp limit. The NEC addresses real-world electrical usage through demand factors. These factors acknowledge that not all circuits operate at full capacity simultaneously. For example, lighting circuits might only be heavily used in the evening, and appliance circuits might have intermittent usage. Load calculations, as specified in the NEC, allow for adjustments based on these realistic usage patterns, preventing overestimation of necessary panel size. When calculating the load on a panel, the NEC allows for the application of demand factors, which reduce the calculated load based on the assumption that not all circuits will be fully loaded at the same time. However, even with demand factors, it's essential to ensure that the calculated load does not exceed the panel's rating. Continuous loads, defined as those operating for 3 hours or more, require special consideration. The NEC mandates that breakers should not be loaded beyond 80% of their rating for continuous loads. This dirtying accounts for heat buildup within the breaker, which could lead to premature tripping if overloaded. In the specific scenario, a 20 amp breaker should not continuously carry more than 16 amps. So, for a 20 amp breaker, the maximum continuous load should not exceed 16 amps. If all 40 20 amp breakers were loaded to their maximum continuous capacity of 16 amps, the total load would reach 640 amps, significantly exceeding the panel's 200 amp limit. If the total load in the panel exceeds its rating, the main breaker will trip. This will cut off power to the entire panel. This action is a critical safety measure, preventing damage to the panel and wiring, and reducing the risk of electrical fires. While a trip breaker is inconvenient, it indicates a potentially dangerous situation and should be addressed. Repeated tripping of the main breaker is a clear sign of an overloaded panel. The underlying causes must be investigated by a qualified electrician to prevent further issues. Ignoring these warnings and simply resetting the breaker can be extremely dangerous. Overloading an electrical panel has several potentially serious consequences, including the following. Firstly, overheating of wires and connections. Overcurrent causes wires to generate excessive heat, damaging insulation and potentially leading to short circuits or ground faults. Loose or corroded connections can exacerbate this problem, increasing resistance and heat. Secondly, damage to electrical equipment. Appliances and equipment are designed to operate within specific voltage and current parameters. Overloading can cause them to overheat, malfunction, and potentially fail prematurely, resulting in costly repairs or replacements. Thirdly, increased risk of electrical fires. Overheated wires and connections can ignite nearby combustible materials such as wood framing, insulation, or paper. Electrical fires spread quickly and pose a significant threat to property and life. To prevent overloading an electrical panel, the following steps are necessary. Firstly, perform regular load calculations. Accurately calculate the expected maximum demand on the electrical system, especially when adding new circuits or equipment. This ensures that the panel's capacity is not exceeded. Secondly, ensure qualified electrical work. Engage licensed electricians familiar with the NEC and local codes for all electrical installations and modifications. Proper installation and adherence to code minimize the risk of overloads and other safety hazards. Thirdly, conduct regular inspections. Periodically inspect the electrical panel for signs of overheating, such as discolored wires, melted components, or unusual smells. Address any issues promptly to prevent escalation. If you suspect that your electrical panel is overloaded, take immediate action. Contact a qualified electrician to inspect the panel, perform a load calculation, and recommend appropriate solutions. Possible solutions include firstly, upgrading the panel. Replace the existing panel with one having a higher amperage rating to accommodate the total load. This provides additional capacity for current needs and future expansion. Secondly, redistributing circuits. Move some circuits from the overloaded panel to another panel with available capacity, balancing the load across multiple panels. Thirdly, reducing load. Identify high-demand circuits and find ways to reduce their usage, such as using energy-efficient appliances, employing timers or occupancy sensors for lighting, and practicing mindful energy consumption habits. The issue of lights dimming occasionally can indicate voltage drops or fluctuations in the electrical system. While it might seem minor, it could be a symptom of an overloaded circuit or panel. Dimming light occurs when the voltage supply to the lights decreases, reducing their brightness. Voltage drops can be caused by several factors, including firstly, overloaded circuits. When a circuit is carrying too much current, the voltage can drop, especially at the end of the circuit. Secondly, undersized wiring. If the wiring is not thick enough to handle the current demand, it can cause a voltage drop. Thirdly, loose connections. Loose connections can increase resistance in the circuit, causing a voltage drop. Fourthly, voltage fluctuations. Variations in the incoming voltage from the utility company can also cause lights to dim. While occasional dimming lights might not always be a sign of a serious problem, it's important to investigate the cause and address any underlying issues to prevent potential electrical hazards. The primary consideration should always be safety and compliance with the National Electrical Code.